So guys, today we are going to understand a concept which is known as projectile motion. It comes under the topic kinematics, and we here understand a motion which is happening in the two dimension. What's two-dimensional motion? The motion in which both the coordinates x and y are changing with time is known as two-dimensional motion. Suppose object is at point O is given some initial velocity u along a straight line. It will continue its motion along the straight line. If there is no frictional force, it will continue its motion along the straight line. This kind of motion in which the motion is happening along only one axis. Suppose we can assume this to be the x-axis. So the motion is only the x coordinate of the particle is changing with time. Suppose this is y-axis, and we throw the object from this point in the upwards direction. It will go along the straight line in the y-axis. It will attain some height, and then afterwards it will come down again and it will strike the ground. So here only y-axis of the object is changing with time. Its x-axis is constant, that is 0, and it's here the x coordinate is changing with time, whereas the y coordinate is constant, and that's 0. So such kind of motions are known as one-dimensional motion. But the projectile motion which we are going to study today is not a one-dimensional motion, it's a two-dimensional motion. What do you mean by two-dimensional motion? A motion in which both x and y coordinates are changing with time is known as two-dimensional motion. So suppose an object is kept at ground at say point O. The ground is, suppose it's the horizontal, we are showing the ground by this horizontal line. Suppose an object kept here is being thrown with some speed u at some angle theta from the horizontal. So this point O from where the object is being projected is called point of projection. The angle that the initial velocity vector makes with the horizontal is known as angle of projection, and the speed with which the object is projected is known as speed of projection. So we can clearly see that the object will go something like this. It will attain some maximum height, will come downwards again, and will collide the ground after some time. So here both the x and y coordinates are changing with time, so this is a two-dimensional motion. In fact, at your level, in foundation level, we are not going to study two-dimensional motion because it involves the concept of vectors. So here we will discuss this entire motion not like a two-dimensional motion, but separate one-dimensional motions. It is not a it is a two-dimensional motion, but we will study this as two one-dimensional motion, one happening along x-axis and other happening along y-axis. These are two one-dimensional motion we are going to understand here. So here the object is being projected from down at angle theta, angle projection theta. So we don't know much about the components of vector. Here as of now I will explain you. You have to learn this much, that if a vector is making angle theta with x-axis, the component of that vector along x-axis is u cos theta, and the component of the same vector along y-axis will be u sin theta. So here, if we write some parameters like initial velocity, acceleration along x-axis and y-axis. So what's the initial velocity along x-axis? It's u, and it's making angle theta with the x-axis, so its component will be u cos theta. So initial velocity along x-axis is u cos theta. What's the initial velocity along y-axis? It's u sin theta. Here no force is acting on the object in the horizontal direction, so all the forces, in fact only one force is there, that's gravitational pull, that's acting on the object along negative of the y-axis. So along x-axis no force, so acceleration is 0. Along y-axis, if we are assuming the upward direction to be positive of y-axis and the downward direction to be negative, and we are hereby we are knowing that the acceleration is along the negative y-axis. So acceleration along y-axis will be minus g. First of all, we will look after time of flight. What is the time of flight? Suppose the object is being thrown from the ground at say angle, at say time t equals to 0. It is on the ground at time t equals to 0. Along y-axis, not along y-axis, the original path of the object will be something like this. Suppose it collides the ground again at time t equals to t of tf. So this tf, the final time at which it is colliding the ground, is known as time of flight. So what is the time of flight? One thing you have to understand here is that all the such motions, that motion under gravity is a symmetrical motion. So the time taken by the object to reach the highest point is equals to the time taken by the object to travel from the highest point to the bottommost point or the ground. So suppose the object reaches its uppermost position or at the maximum height at say some time t. So we know equation of motion v equals to u plus at. Equation of motion v plus u at, where v is the final velocity, u is the initial velocity, a is the acceleration, and t is the time taken or the time interval. So if you consider motion along y-axis, we are only here we will consider motion along y-axis. So at time t equals to 0, the object is at the ground, and at time t, the object reaches its maximum height. Say something, it will be its value is something, but we are not hereby we are not concerned about that. So at the maximum height, you know that the final velocity becomes 0. Use the initial velocity. We have seen that along in the previous slide. We saw that the initial velocity along y-axis is nothing else but u sine theta plus a. We were assuming thermal direction to be negative, so a here will become minus g, and then t. T is the time interval in which the object reaches to the highest point from the bottommost point. So from here we can calculate time is u sine theta by g. Now I told you earlier also that the motion under gravity is a symmetrical kind of motion, where the time taken by the object to reach the highest point from the ground is equals to the time taken by the object to reach the bottommost point from the uppermost point. So if we have to write total time of flight, we can easily write it is 2 times the time taken by the object to reach the highest point from the bottommost point, 2t. T is 2u sin theta by g, so time of flight becomes 2u sin theta by g. So we have come to know about the total time of flight of the object. Secondly, we are concerned about the maximum height the object attains once it has been thrown from the ground. What is the maximum height attained by the object from the ground? Now here also we will consider motion along y-axis. Everywhere we are dealing with the projectile motion as a one-dimensional motion along x or y-axis. So again here we are taking the motion along y-axis. We are considering motion along y-axis. So we have to find the maximum height or the maximum y coordinate it attains along its motion. So suppose the object is being thrown from here at some speed u and angle theta, and final position is u. Suppose it comes down here and collides the ground again here. So this is the maximum height attained, h max. We have to calculate h max. So along y-axis, we know equation of motion. V square is nothing else but u square plus 2as. We know that in a one-dimensional motion, whenever the object is changing its direction of motion, it must reach a constant velocity that is equals to 0. Or else you can see here. See also here the moment at which it attains its maximum height, its velocity along y-axis will become 0. What's u square? U square here what's u? U is the initial, we are considering motion along y-axis. So u is the initial velocity along y-axis. So we'll write u as u sine theta whole square plus 2 acceleration, again here it will become minus g, as is h max. So after calculating, you can simply write h max as u square sine square theta by 2g. So we have come to know about the time of flight and the maximum height attained by the object along throughout its motion, that's h max. Now we'll come to know about range. Now we are going to know about range. What's range? Suppose the object is being thrown from the ground. Let's say this point of projection is O, angle of projection is theta. It will go like this and will come and collide the ground again at some time. Time is time of flight. So this distance is known as range. The horizontal distance traveled by the object along while undergoing the motion. That's known as range. How will we calculate range? Here we are not going to consider motion along y-axis. Here we will instead consider motion along x-axis. This is x-axis. So you know that what's displacement or distance? It's speed into time, right? Distance we know is the range. We have defined the distance is nothing else but the range. What speed? We know that the speed of the object along x-axis will be a constant value because there is no acceleration along x-axis. So whatever the initial velocity was there, throughout the motion along x-axis, the speed will be same. That will be u cos theta. And then time. What's the time? We know that the time at which the object collides the ground is known as time of flight. So you can directly put the value of time of flight here, 2u sine theta by g. You can write here u square 2 sine theta cos theta by g. In trigonometry, you will come to know about a formula which is sine 2 theta is 2 sine theta cos theta. So 2 sine theta cos theta here can be replaced by sine 2 theta. So the range comes like this, u square sine 2 theta by g. So here we have been given a question that an object is projected with angle theta 45 degree from the ground and at a speed 40 root 2 meter per second, and we have said to calculate the time of flight, the range and the maximum height attained by the object. So first of all we will draw a diagram to illustrate this. Suppose this is point of projection O, this is x-axis, this is y-axis. Object is being thrown at angle, what's the velocity? 40 root 2 meter per second, and the angle which it is making with the angle of projection is 45 degree. So first of all we have been said to calculate time of flight. So from the formula you can simply say time of flight is nothing else but 2u sine theta by g. 2u is 40 root 2, sine 45 is nothing but 1 by root 2, and then we are dividing it by 10. So it comes root 2 gets cancelled, 10 gets cancelled, 8 seconds. So the time of flight is 8 seconds. Secondly, we have been said to calculate range. Now what's range? Range is nothing but u cos theta, velocity along x-axis, into time of flight. Time of flight was 8 seconds. U cos theta, u is 40 root 2, cos theta is 1 by root 2, cos 45 is 1 by root 2, and time of flight was 8. Root 2 gets cancelled, it becomes 320 meter. The range comes as 320 meters. Then we are set to calculate maximum height attained. we know formula for maximum height, that is u square sine square theta by 2g. U is 40 root 2 into 40 root 2 for u square. Then sine square theta, sine theta is 1 by root 2 into 1 by root 2 by 2g, 2 into 10. Root 2 root 2 root 2 root 2 gets cancelled. It becomes 1600 by 20. That's 18 meters. So from the above illustration, we have seen that how to calculate time of flight, range, and maximum height attained. In the next lectures, we'll come to know about there are some relations like the maximum height. There is a relation between the maximum height attained by the particle and the range. Then we can calculate the velocity with the object will collide the ground again, or the velocity at the maximum height. We'll come to know about these things in the upcoming lectures. Thank you.